that range where you switch
All
over.
right.
Yeah. Mashed potatoes.
Hi,
I've never heard
Sean.
of Christmas
Hi,
in July.
Abby. Okay, you ready?
That was your intro.
Yeah.
Hi, I'm
No
happy.
bagel today.
No, I said hi, Abby.
Oh.
No hi to Sean.
I said Sean too. Good.
Hi, Sean.
Shh, gosh.
Hey Sean, I'm still on camera.
You're gonna ruin the lesson for them, aren't you?
Yes.
Yeah.
The answer is yes.
I know. I know. All right, so
It's gonna be the worst
there
camera
are
shot of all
two
time.
main kinds of word problems. The first was related rates that we already did, and then we looked at that latter one the other day. And the second is called optimization. And the difference is, with a related rate, it would be like, how fast is this rate changing as this rate is this, and blah, blah, blah. It's all about like how fast is something changing. Optimization is usually like, what will give you the biggest or the smallest, whatever, distance or volume or whatever. So that's why it goes after the max-min stuff, because we just did max-min stuff. Now we're going to do max-min word problems. They have like a list. I kind of try to make a list of the steps you should take in order to solve them. Bless you. They're pretty straightforward, but I don't know. That's straightforward. So anyway, let's read the first one, then we'll go through the list of how to put it together. So step one, or problem one. A manufacturer wants to design an open box having a square base and a surface area of 101 square inches. What dimensions will produce a box with maximum volume? So you can get that, like, these are actually problems that someone is doing at a company. You know, like, we want it to hold this much stuff, we want to use the least amount of a product, go. What should the dimensions be? So it actually kind of makes some sense. Okay, first thing I was going to do is draw a picture. So if you want an open box, and it's got a square base, draw it. I drew myself a picture. I actually prepared so that I wouldn't be embarrassed.
When you say open box, do you want like the flaps up or just completely gone?
Oh my god. It just means there's no top.
Alright.
There's no top.
The flap.
Because it adds surface area.
Should there or should there not be flaps?
You've been telling yourself.
Look at that box.
It's a rectangle.
Seriously?
It's pretty
What? I practiced.
What the heck? What is that? Someone didn't use a ruler. How off that is.
What?
No, you draw. No,
What are you doing?
Might as well just draw a circle.
you draw that.
You prepared, didn't you?
What's going on?
You should brag about preparing.
And there's no background.
This is better than mine. Mine is copy this.
Right? Come on now. That's a good box.
Come on, man.
Eh.
Come on.
Come on, everybody.
Just a jerk.
Okay. Draw a picture, because usually we're talking about a picture or a graph.
Because you hate
Second
boxes.
step, find out what is to be optimized. So optimized means maxed or minned. So what am I trying to get? The biggest what? Volume. Okay, what dimensions will produce a box with maximum volume? So volume is what I'm trying to maximize. So I want to get a formula for that. I can label the picture however I want. I mean, like yeah, whatever letters I want. It has a square base, so I definitely want to have the length and the width be the same variable. And then maybe I want each for the height. So in this section, they don't really give you the formulas. You know, in related rates, they would say, like, the volume of a sphere is this. Now you're usually coming up with it yourself. So what is the volume of a box? Length times width times height. So length times width times height. So we got x squared times h. Okay, the good thing about this also is when we take derivatives, it's not going to be with respect to time. So we don't have to always chain on. So that's a related rates thing, because everything's with respect to time. This is just going to be like normal. Step 3, get down to 2 variables. All right, I'm going to be taking a derivative, but before I do, I don't want an x and an h. It's going to screw me up. So I'm always going to replace one of these with respect to the other one. So there's always another piece of information. What is it?
Surface area.
Surface area. Okay, they told you that the surface area is 108 square inches. So somehow I can come up with a formula for surface area, solve that for x or h, and put it into the volume. So surface area, this is an open box. This is where this is important. The openness didn't matter for volume, but for surface area it does, because I have no top. So surface area is, just remember, it's taking the area of all the sides and adding it up. So the area of the bottom is going to be x squared the area of each side?
XH.
XH, and how many do I have? 4 of them. So the surface area of this box is the area of the bottom plus the area of all 4 sides, and that equals 108. So without explicitly stating it, they've given you a second big piece of information. I want to solve this for one of the variables. It doesn't matter which one, but in this case, what is a lot easier to solve for?
H.
H. If I solve for x, I'm going to be really stuck because I've got x connected to both of them and I'm not going to be able to factor it out or anything. So I want to solve for h. So h is going to be 108 minus x squared all over 4x. So when step 3 says get down to 2 variables, this is what was involved. Finding another equation that you can use, solving that for something, and now plugging it into this. So I'm going to replace h with 108 minus x squared over 4x. Is that okay so far?
What does it say when it means look at the constraint?
Where is that? Oh, look at the constraint. This is called the constraint. This is like, tell me what the maximum box is, but it has to fit into this parameter, into that constraint. Because like, if it just said what's the maximum volume of a box, it'd be like,
That's a
infinity, infinity, whatever. So there's a constraint like that you have to like abide by. Okay, the 4th step is simplify. I don't want to take a derivative.
even
What'd
respond.
you do, bro?
Nothing.
Look at his paper.
What?
Right.
The folded up one?
He's just folding it.
Get on it.
It's an awkward fold pattern.
It's not done yet. Yes, that's a plan.
Alright, before you we're going to
In
take the
defense of
derivative
your plane.
in a second, but before you do, you want this to be as simple as possible. So let's like distribute the
It's pretty
x
simple.
squared.
That's simple.
Let's get rid of the x. So we want to get it in as like, it's most easy to take a derivative of form. And this is where you just have to really like know your derivatives. So if I do take an x out, I'd have 108 x minus x to the 3rd over 4. And even that is a little annoying because of that 1/4. I think this would be a lot easier to take the volume if I split this into 2 separate fractions. 108 over 4 is 27, is that right? And then this is 1/4, x to the 3rd. That's a lot easier than this big fraction that I would need like quotient rule or something. Okay, so pause for a second. I haven't done any calculus yet. I drew a picture. I figured out what they wanted the max or min of. I went over to the constraint, which is like the other information, so I could replace one of these variables. And now I'm just like simplifying this so I'm ready. Okay, now I'm ready to take a derivative. Because think about what I'm doing. I'm trying to find what's the max. What's the biggest volume I can get? So I want to find out when does this have a max. So now I'm kind of just back to normal, what we've been doing. To find where something has a max, I want to find out where its derivative changes from positive to negative, just like before. So the derivative of v is going to be 27 minus 3/4 x squared. If I'm finding a max, what do I do with that?
0.
Is it equal to 0? I can also find out where it's undefined, but I don't have any x in the denominator, so I don't have to. And solve for x. So I'm going to have like 36. So x is positive or negative 6. Got all that math? Is that okay? Okay, now here's the thing. I wrote down number 7 to test it. Technically, we should test 6. Do I have to test negative 6?
No.
No. What if I'm talking about a box? It's not going to have a dimension of negative 6. I should test 6 and make sure that the derivative of does change from positive to negative, so that I'm making sure that this is a max. Here's a time-saving tip. Don't do that unless you have two real possibilities. If your answers were like 2 and 4, okay, test 2 and 4 and see which one is the max. But if you only have one answer, that's the answer. If I do go plug it in, and just to make sure, if I plug like 0 in, I have a positive. If I plug like 7 in, well, that's gonna be gross, but whatever. If I plug in something bigger, this is gonna be really big, and I'm gonna have a negative. So it does work. But I would only test it if I have 2 viable options that I need to choose between, otherwise I'm good. Last step, answer the question. So if this is an open-ended question, you want to give an answer. The question said, what dimensions will produce a box with the maximum volume? What is 6?
That's your X.
That's my X.
That's nice.
So that means my dimensions are going to be 6 by 6 by, well, if X is 6,
108
we go find the H.
36.
108 minus 36 divided by 24, I will just tell
24.
you, is 3. And is this inches? Yeah. Done. Is that okay? Don't you feel like these are a little easier than linear rates, maybe? They're a little more straightforward. Okay. Let's do number 3 next, and then we'll go back to number 2. Because number 3 you see a lot.
Jared's still sleeping. Are you trying to say that Jared? Are you trying to say that Jared does anything bad? Because you'd be wrong.
What are you doing?
Nothing.
Gosh. Just kidding. Alright, take a second and read 3.
Read number 3.
Just keeps whispering.
Brooks, I gave you a notebook.
Right?
Whoops.
Whoops.
He couldn't see it.
That's right.
Couldn't
24
see.
square inches.
24.
God.
You immediately point that. Right.
What does that even mean?
Ah, I didn't know.
You have a couple options of what you want to make X and Y. Here's my tip. So you've got this like rectangular print in the middle, and you've got the page, right? You've got
that's what
margins. There's a 1.5 inch margin at the top and at the bottom, and there's a 1 inch margin on either side. You can call the print X by Y, or you can call the page X by Y. There's one way that's a lot easier. Because they tell you the page is to contain 24 square inches of print, it's going to be a lot easier if I call this length X and this height Y, so that my constraint, or whatever we want to call it, is just X times Y equals 24. Because if this is X, what am I going to call the whole sheet of paper? What would I call this length? X plus 2. Does that make sense? I've got 1 inch on either side of the print, so the whole width is X plus 2. And then this is going to be Y plus 3. If I had done it the other way around and called this X and then called this X minus 2, it wouldn't be wrong, but my constraint would be like X minus 2 times Y minus 3 equals 24. It just would have been a little more complicated. I wouldn't do that. I would try to make my constraint kind of simple so that I can easily plug it into the main thing. It doesn't matter. Either way is going to be okay. Does that make sense, what I did? So I've got this print on the inside. I'm going to call it X by Y. The page then is X plus 2 by Y plus 3. So I'm trying to minimize the dimensions of the page. So what is that? I'm talking about minimum, and I'm talking about area of the page. So if I want to minimize the dimensions, I want to get the smallest page possible. So I'm just talking about the area of the page.
That's what needs to be optimized.
Optimized. So maxed or minned.
Oh.
Maxed or minned. So yeah, I don't know.
Optimization.
is talking about what's my biggest or my smallest. So I don't know what exactly that word means. If I was to look it up or whatever. So, what's that? Like a transformer? Optimus Prime optimizes. Why are you so annoying?
I'm not doing anything.
Gosh.
I'm just trying to learn.
Yeah.
You're talking about like transformers and stuff.
Yeah, right.
So distracted.
Okay, so the area of the page is x plus 2 times y plus 3. Go ahead and see if you can finish it out. Replace one of the variables, take a derivative, set equals 0, yada yada.
You don't have to do the same like y prime thing as this, do you?
What do you mean?
Would you have to like put y prime there?
Well, you have to note.
Okay, so
You don't have to chain on like that. It's only related rate because it's with respect to time. Now we're fine. Sure.
That works.
Yep. This should get you to the same thing. Alright, so I plugged in for y. I got to here the area of the, the derivative of the area. I just wanted to make a comment on something that, when we do maxes and mins, you know how you have to set the top and bottom equal to 0? If I make a common denominator out of this, what's going to make the denominator equal to 0?
0.
0. So I don't have to worry about that, because I can't have the dimension be 0. So sometimes you can make less work for yourself by just thinking for a second and be like, I don't have to worry about the bottom as being 0. I can just set the whole thing equal to 0 and go from there. Or if I did make a common denominator out of it, then that's fine. Just set the top equal to 0. You're going to get the same answer either way. So I can either set the entire thing equal to 0, bring the 3 over, maybe cross multiply and solve for x. Or I can make a common denominator if you're used to doing that. Don't worry about the bottom being 0 because it's not going to ever happen that way. And only set the top equal to 0, so we're going to have x squared equals 16. Did you get plus or minus 4 for x? So I don't really have to test it because all I really have is viable option is 4, and that's going to work. If I did test it, I want at least, it would work out. They're just kind of set up to work out. So if x equals 4, don't forget to answer your question. They want, what's the dimensions of the page, right? So if x is 4, we're going to have 6 inches by, if x is 4, what's y? 6, so the other side is 9. So did you get then for y, 6? If you did it the other way? Alexa, did you guys get 6 for y?
No, I didn't finish it.
Okay. Are you okay with it?
Yeah.
Are you sure?
Yes.
What are you plugging in for? Sorry.
It's okay. So once I get 4 is x, I go back over here to what I've got. So if x is 4, then y's got to be 6. And if x is 4, the page is actually 6, and if y is 6, the page is actually 9.
Okay.
Okay. I don't want to rush it. Is that okay? Kelsey, are you okay?
Yeah, I accidentally messed up like part of the derivatives and going back and like fixing it.
Okay.
But I know how to do it.
All right. I just feel like sometimes with easier stuff, I go so fast that it becomes hard. Those were 2 like fairly simple ones. Tomorrow we'll do one that's awesome. Christine in the Desert is a great problem. I'm so excited. And we'll do one other one that's a little bit harder. And then you don't have to do a ton of these. So tonight just try 2 on page 215. Try 3 and 9. It's good because they're going to be different. You don't want to practice the same kind over and over again because they're going to see different stuff when you take the test.
Poor Christine.
Ah, Jared, what are you doing?
What are you doing?
Jared's a great kid. Don't accuse him of anything.
Ah,
Jared,
yeah.
Jared will never do anything bad.